today's class we are going to talk about the salt hydrolysis. We must know what is called salt. The salts are obtained by the neutralization of an acid by base. When an acid is reacting with the base, we can get the salt plus water. And this particular reaction is said to be the neutralization reaction. So as a result of the neutralization, we are obtaining a particular salt. Thus obtained salt might be dissociated into the cation and anion, the constituent ions in the water. The slurred cation may react with water to form a product. Likewise, the slurred anion may also react with water to form a product. Otherwise, both cation and anion can act with water to give a product. So, this is what is known as hydrolysis of salt. By the action in between the cation from the salt and water, the anion from the salt and water, or both cation and anion from the salt and water. This is to be discussed in the topic called salt hydrolysis. The category 1, we can take a salt which is obtained from stronger acid and stronger base. Stronger acid and stronger base. Consider the following stronger base, NaOH, sodium hydroxide, in its aqueous solution. If it is reacting with a nitric acid in the aqueous medium, the result would be NaNO3, sodium nitrate aqueous. In addition to that, we can get water, H2O. So, this salt is obtained from the stronger acid called nitric acid, and the stronger base, it is nothing but sodium hydroxide. The salt which is obtained here is getting dissociated as follows: NaNO3 aqueous. If it is dissociated, we can have Na plus ion and NO3 minus ion in the aqueous solution. So, two ions are formed. Now, further, Na plus and NO3 minus obtained here is actually the conjugate base of HNO3. HNO3 is a stronger acid, we know that. You know the difference in between the conjugate acid and base. HNO3, its conjugate base is NO3 minus. So, NO3 minus has no tendency to attract H plus from water. Try to understand. Because HNO3 is dissociated to form H plus and then NO3 minus. Once NO3 minus is obtained, this is not having the tendency to combine with the H plus. It means it do not act with water. It is just due to, it is a conjugate base of HNO3. Likewise, you consider the other one. You see the other ion. What is the other ion of the salt? It is Na plus. Na plus, it would be the conjugate acid of NaOH, the stronger base. Once for all, NaOH is dissociated to form Na plus and OH minus. Now, Na plus has no tendency to form compound with OH minus. So NO3 is not combining with the H plus. Na plus is not combining with OH because it is the conjugate base of HNO3. The Na plus is the conjugate acid of stronger base called sodium hydroxide. And we know that once water is taken, that will be dissociated to form H plus and OH minus. So the hydrogen ion content, the concentration of hydrogen ion is exactly equal to the concentration of hydroxide ion in this particular case. No variation of H plus and OH minus because H plus is not attracted by the HNO3 and OH minus is not attracted by Na plus. So no variation in the concentration of both H plus and OH minus. It means the resulting solution, the solution of this particular category, solution of this salt remains neutral. It is neither acidic nor basic as this is having equal concentrations of both H plus and OH minus. So this particular salt solution is neutral, and this is the explanation for this particular case. Okay.